All right, welcome. Today we're going to discuss 6.3. So here we are. 6.3 is on matrices and system of equations. So a matrix is kind of just a way of dealing with a system of equations without dealing with the equations. For example, if I have a system of equations that looks perhaps like this, what we're going to do is rewrite this with just the numbers. I'm going to get rid of the x's, I'm going to get rid of the y's, I'm going to get rid of the equal sign. So I'm just going to write the coefficients in front of the variables, and then the numbers on the right-hand side, the 7 and the -2, the constants. So this looks like this: a 2, a 3, a 7, a 1 in front of that x here, and then a 4, and a -2. And this is a matrix. It's kind of like an imaginary compartmentalized box where these, well, these lines don't exist in the matrix, but there are those compartments. The 2 is up in itself. It doesn't interact with the 3. The 3 is there. The 7 is there. So, oh man, I dotted my line, so this will take forever. But this is the matrix right here. The one thing that you will see is when you write the coefficients, that 7 and -2, a lot of times you'll see a bar that separates the left-hand coefficients from the right-hand constants. And so if I take just this left-hand side and don't write the 7 and the -2, if I don't write those constants, this part of it is called the coefficient matrix. But if I do write with that 7 and -2, so this matrix that I wrote initially is called the augmented matrix, meaning that it's simply been augmented with the right-hand side of the equal sign with those constants. There are times where you'll want to use just the coefficient matrix, and then there are times when you want to play with the augmented matrix. For most of what we're going to do today, we're going to play with the augmented matrix. Okay. So the material that we covered in the last section, in section 6.2. Did I write 6.3 or 6.2 up here? Yeah, 6.3. All right, so what we covered in 6.2 was the Gaussian method for solving a system of 3x3s, for example. And you can apply that in matrices, and it's actually a very good idea to play with it here. Again, though, like I said in class, it's not always the best idea to follow a very rigid, set of this is what I have to do, and now I have to, change things this way or that way. But to be flexible with those. But we'll talk about how to use the Gaussian method in these matrices. So there are some things that we can do, some things that we can't do. So this is the exact same list of things that you can do that we talked about when we had a system of 3 equations and 3 variables. I can swap 2 rows. I can multiply 1 row by a number, as long as that number is not 0, as long as I, multiply everything on the left and everything on the right by that number. So what that means in a matrix is if I just multiply every single thing in that row by that same number. And then, of course, the last one here, number 3, I can add a non-zero multiple of 1 row to another. And that's what we've been doing in the last section. So what I want to do is be able to do these in a matrix format. And so we'll talk about what that looks like. So let's, excuse me, take a look at a system. Oh man, excuse me. So here's a very large system. All right, so I have that. There's my system. The very first thing I want to do is to rewrite this in matrix form. So this becomes, in a matrix, I just write these numbers: 2, -1, 4, and I'm going to augment this one. So I've got -3 over here. And then I've got 1, -2, -10, and -6. And then I've got 3. There is no y term in here, so it's a 0. And then 4 and 7. And so this is my matrix. Okay. Now the idea when we did this Gaussian method with regular equations was to end up with something that looks like this. Right? That was the idea, and we could go back and solve. What we want to look for now instead is a matrix that looks like, and I'm just going to copy it here. I want a matrix that looks like this. Okay. So if I can get my matrix entries to be ones down this diagonal, here, here, and here, all right, if I can do that, then right off the bat, this corresponds to the system of equations: x plus some a times y plus some b times z is equal to c. And then there's no x's in the second one, so it's just a 1 times y, so it's y plus dz equals e. And then 1 times z is equal to f. And if I can get down to here, I've already solved for f, and then I just back substitute into the previous one, solve for y, and I back substitute in previous one and solve for z. So this is the Gaussian method. If I can get ones down here, I've already got f, and then I can back substitute into these equations and solve for x and y. Right? We'll talk about this for 1 minute, but then we're going to talk about what Gauss's student Jordan came along and said, "You crazy old man, why did you stop here? Keep going with this." And the Gauss-Jordan method is, in my opinion, nicer because it solves it all in one go. So what do I want to do with this? I'm going to clear myself some space here. What I want to do is initially, maybe I didn't want to clear all of that space. I still want this hanging out. So what I want to do, the very first thing that I want to do is to try to get this to be a 1. That's step 1 for me. Right? And I can do that because I can swap rows. So rather than try to manipulate this 2 somehow, I have a 1 sitting right here already. So I'm just going to use it. I'm going to say, I'm going to swap rows. Right? And when we're using matrix operations, you can indicate this in a certain way. You can say my old row 1 by using a lowercase r1. And I'm going to draw an arrow and say that becomes my new r2. Capital means new, and then it's row 2. And likewise, this row 2 becomes my new row 1. And then my row 3 doesn't change, it stays as row 3. And so Writing these is kind of more like notes for yourself or notes for somebody else that comes along and has to look at this. But it's just telling you what's happening. So I'm just swapping these. So row 2 becomes my new row 1. So that's now 1, -2, -10, and augmented with -6. And then 2, -1, 4, and augmented with -3. And then row 3 stayed where it was. And so 3, 0, 4. And 7. So step 1 for me is complete. I've got a 1 in that upper left. Now, step 2 for me is going to be, step 2 is going to be to zero out the x's in those 2 rows. And I'm going to do that. We've done this in equation land. We're just going to do this now in matrix world here. And what I'm going to do is take the advantage of the fact that I have a 1 sitting right there, right? This is a 1. I'm going to take advantage of that fact by saying each of my rows below it, I'll just take -2 times that row 1 and add it to row 2 and put that into my new row 2. Likewise, I'm going to do the same thing with -3 row 3, or sorry, -3 row 1, and add that to row 3 rather, and that's my new row 3. And then row 1 itself just stays as row 1. But I do that specifically because if I take -2 times row 1 and add it to row 2, I'm taking -2 times that 1, which is -2, and I'm adding it to the 2 below it, and that zeroes it out. So you can do this on the side if you need to. -2 times row 1, I'll write that, is -2, -4, nope, not -4, +4. -2 times -10 is +20, and then -2 times 6 is +12. And then I'll just write row 2 below it, 2, -1, 4, and -3, and I'll add those 2 rows together. Element by element, -2 and +2 is 0, +4 and -1 is +3, 20 plus 4, 24, and then 12 minus 3, 9. And this is my new row 2. And I'll do the same thing with row 3, right? -3 times that row 1 is negative, let me just get that, oops, that's all gone now. Give myself a little bit of room here. -3 row 1 is -3, +6, -3, so +30, and then 18. Just having multiplied that -3 through that top row there. And then I'm gonna, add row 3 to that. So 3, 0, 4, and 7, and I add those. -3 and 3 is 0, right? And again, that's what I was looking for, is to zero out the x component here, zero out the x component here, and I did that. So continue on with that. 6 and 0 is 6, 30 and 4 is 34, and then 18 and 7 is 25. Okay, and that's my new row 3. So my whole system now is this, and it's an equivalent system. It's all the same planes out there in space. We're just manipulating the equations with each other. So I have row 1 didn't change. That's 1, -2, -10, and -6. My new row 2 is here. So that's 0, 3, 24, 9, and my new row 3 is there. There. So it's 0, 6, 34, and 25. And bit by bit, we're getting there, right? My first column now looks like the first column of the end product that I want. So the next thing that I want to do in Gaussian elimination, my step 3 is going to be right there, is to get that to be a 1. And I can swap rows still. I definitely don't want to swap it with row 1 because then I pull back down an X element into that 0 that I want to stay 0. I can add or subtract the row below it, but everything in that row is divisible by 3. So I'm just going to take 1/3 multiplied by row 2, and that's going to become my new row 2. Row 1 doesn't change. So a lot of times I just write an arrow instead of lowercase r1 goes to capital R1. It just moves over unchanged. So what's my new system then? The top didn't change. The camera's in my way. And now the bottom didn't change. 0, 6, 34, 25. But what did change was that middle row. I'm just multiplying everything by 1/3. So 0 times 1/3 is still 0. 3 times 1/3 is 1. That's what I want there. And then 24 divided by 3 is 8. And then 9 multiplied by 1/3 is 3. And now the next thing I want to do after that is step 4 is to get this guy right there to be a 0. Right? So that's this 6 right here. I want that to be a 0. I'm going to use the same technique I used to zero out the x's, and I'm going to utilize the fact that I've got a 1 sitting right there. Right? And I definitely don't want to try to use this -2 up there, because if I add any multiple of row 1 into row 3, it's going to change my x that is a 0 in row 3 to be not a 0 anymore, and I'm undoing stuff that I've done, and I don't want that to happen. So I'm going to move this because I can't see because my camera's right planted in front of my screen here. And that should be fine. So I've got, let me just give myself a little room. Okay, there we go. I'm trying to zero out this 6, so I'm going to take -6 multiples of row 2 and add that to row 3. And that becomes my new row 3. So I'll do this just right here on the side, right? -6 times row 2, well, -6 times 0 is still 0. -6 times 1 is -6. -6 times 8 is -48. And -6 times 3 is -18. And then row 3, I'm just going to add that in. So 0, 6, 34, and 25. And I've got 0, 0. What is that? 14. -14, right? And then 7. Okay. So everything else stayed the same, right? Row 1 didn't change. Row 2 didn't change. So my new system, I'm going to write right here. Is 1, -2, and -10, and -6, and then 0, 1, 8, 3. And then this is my new row 3. So I've got 0, 0, -14, and 7. And now I'm going to divide row 3, or I'm going to multiply row 3, if you will, by -1/2. And that's my new row 3. Right? And again, I'm doing that because I'm just kind of following this pattern that I've started out here. The pattern is get a 1 and then zero out everything below it. Get a 1, zero out below it, and then I want to get a 1 here. That's the 5th and final step for matrices in Gaussian form. And so I'll just multiply everything by 1/2, -1/2. And that now becomes this system, 1, -2, -10, -6, and 0, 1, 8, 3, and 0, 0. And I'm going to back up. I don't know why I chose -1/2, because I did the math in my head, probably. But I want this -14 to be a 1, so I'm going to multiply by -1/14 times row 3, and that becomes my new row 3. I apologize for that. But I do that because -1/14 times -14 is 1, and that's what I want there. -1/14 times 7 is -1/2. And I'm done with the matrix at this point, because this row right here tells me that z is equal to -1/2. The equation above it tells me that 1y plus 8z, but z is -1/2, is equal to 3. So that is to say 8 minus 4 is equal to 3. And so then if I add 4 to both sides, I get y is equal to 7. And then my last bit up here, this top equation tells me that x minus 2y, but y is 7, minus 10z, but z is -1/2, should equal -6. And so I'm just doing my back substitution, solving this. X minus 14 plus 5 should equal -6. -14 plus 5 is x minus 9 equals -6. And then add 9 to both sides, and x equals 3. Then I have my system solved. Okay. So our solutions look like this then. X is 3, y is 7, and z is -1/2. And that is the one and only solution to this system. All right. And you can check that by going back up into the original system. X is 3, y is 7, z is -1/2, and plugging it into each of those equations up here and making sure that they do end up having the left side equal the right-hand side. So that is the Gaussian form. It's also called row echelon form. So I'm going to post this here. That's Gauss's method, but we call it, when we're in matrices, row echelon form. Right. So the idea was to get leading ones and then zero out everything below them. But a row itself does not have to necessarily be completely zeroed out. As we saw, we had these A, B, and D's to the right of our ones, which is totally fine. But if we want to then say, well, Jordan, who was Gauss's student, came along and said, well, why would we stop there? And he said, why don't you just keep going with matrix and do it in what's called now reduced row echelon form? And if you do that, let me see if there's a picture I can still, well, no. But if you can do that, you end up with a matrix that looks like this. All right. This is reduced row echelon form, where now not only are we zeroing out everything below the ones, but we zero out everything to the right of the ones as well, right? Or you can look at it as zeroing out things above the ones as well as below the ones. And if we do this, this system translates over to 1x plus 0y plus 0z is equal to A, and then 0x plus 1y is equal to B, and 0x plus 0y plus 1z is equal to C. And if you get it in that form, you're done. You have x, you have y, you have z. And so this is called the Gauss-Jordan method or elimination. A lot of people find it easy if you're doing Gaussian elimination just to go all in and do the Gauss-Jordan elimination from the get-go. So let's do the same matrix that we just did. Still this so we don't have to scroll back up. But using that elimination method, we got to this matrix, which is this. And now we want to continue on and just say, well, rather than going back and resubstituting like Gauss did, let's take it all the way like Jordan did and say, I want to eliminate that -2. So let's start there. And to do that, I'm going to take 2 multiples of row 2 and add that to row 1, and that's my new row 1. And that's all I'm going to do because I've already zeroed this guy out, so I don't need to worry about it. So my new system becomes, my bottom doesn't change, right? It's 0, 1. Let me get rid of this odd guy. 0, 1, 8, 3, and 0, 0, 1, -1/2. But if I do the top 2 row 2s plus row 1, well, 2 times 0 is 0. And if I add that to 1, that's 1. That's great because I need that 1 where it is. 2 times 1 is 2, plus -2 is 0, so that's 0. And then 2 times 8 is 16, plus 10 gives me +6. And then 2 times 3 is 6, add -6 gives me 0. So continuing on, the next thing that I want to do is zero out this 6 and this 8, and I can do that at the same time by taking -6 multiple row 3 and add that to row 1 to become my new row 1. And I can take -8 multiple of row 3 and add that to row 1 to become my new row 2. Not row 1, row 2 added in there to become my new row 2. And what happens here then? Well, my bottom equation doesn't change. That's 0, 0, 1, and -1/2. And I don't want that to change because this is already solved for z. Z equals -1/2. Let's start with this top guy here, though. -6 row 3 plus row 1. Well, -6 times 0 is 0, and if I add 1, that's still 1. -6 times 0 is still 0, and if I add 0, that is still 0. That's great. And then -6 times 1 is -6, and I add that to the top 6. That gives me 0. Perfect. That's what I want. And -6 times -1/2 is a +3, and if I add that to 0, I get 3. And then this guy here, -8 row 3 is added to row 2. But -8 times 0 is 0, plus 0 is still 0. -8 times 0 is still 0, plus the 1 gives me the 1. And -8 times 1 is -8, plus +8 gives me 0. So my coefficient matrix is exactly how I want it. And so -8 times -1/2 is a +4. Add that to 3 and I get 7. And I'm done, and it's the same answer. X equals 3, Y equals 7, and Z equals -1/2. And I'm done. Okay. So that's not helpful. Let's see this whole process done on a system of equations. So here I'm going to do Gauss-Jordan, which is my preferred way Again, I don't care how you do it on your exams. But if I've got, I'm just going to still a system here. Let's do let's do this one. Hopefully it works out. If you watched yesterday's fiasco with the dietitian problem, that turned it pretty ugly pretty quick. But hopefully this doesn't. So I'm going to start with this system. I'm going to first write it as an augmented matrix. So 1, 2, -3, 9. 2, -1, 2, and -8. And then 3, -1, -4, and 3. Okay. So the first step, I want to get a 1 right there, and that's done. So that was easy. Next. The next thing I want to do is to get zeros where my 2 and 3 are. So I'll do that by taking -2 row 1 and adding it to row 2. And I'll take -3 row 1 and add it to row 3. That'll be my new row 2 and 3. So my new system, 1, 2, -3, and 9. And then -2 row 1, so -2 multiplied by row 1 in the x column gives me -2 plus 2 is 0. -2 row 1s, -2 times 2 is -4, plus -1 is -5. -2 times -3 is +15, plus 2 is 17. And then -2 times 9 is -18, plus -8 is -26. And then the bottom part here, -3 row 1s, so element by element, -3 times 1 is -3, plus 3 is 0. All right, and I'm not writing it down anymore, but hopefully you're following along with what's happening. -3 times -2, or sorry, -3 times 2 is -6, plus -1 is -7. So that goes here. -3 times -3 is +9, plus -4 gives me a +5. And then -3 times 9 is -27, plus 3 is -24. So that's my new system. The next thing that I want to do is get a 1 right here. And I don't want to just divide the entire row by 5 because 17 and 26 are not divisible by 5. So that's not going to be terribly helpful to just divide by 5, because then I'll get fractions and I don't want them if I can avoid them, right? So what I want to do instead is perhaps take some multiple of row 2 and add it to row 3. And if I just note here that I'm dealing with a -5 and a -7, but -5 times 3 is -15. And then if I, instead of doing times 3, I multiply it by a -3, that's now a +15. And if I take this -7 and I multiply it by 2, that's 14, -14. And if I add those two things together, that gives me 1. And that's what I want to do to these rows, right? In row 2, I'm going to multiply it by -3. And then to that, I'm going to add on 2 multiples of row 3. And that's my new row 2. I'm going to write this one out because it's a lot going on, and it's easy to mess these up when you do it in your head like I just did a couple of times. But here it is. -3 row 2 is -3 multiplied by this entire row. So -3 times -5 is positive 15. -3 times -17 is negative 51. And then I'm going to check my work because I definitely don't want to mess up here. And then 26 times -3 is 78. And this first thing, 0 times -3 is 0, so I should write that as well. And I'm going to multiply row 3 by 2, so that's 0, -14 by 2, so positive 10, and then -48. And I'll combine those. 0 and 0 is still 0. 15 and -14 is 1. That's great. That's what I was looking for. -51 and positive 10 is -41. And then 78 minus 48 is 30. So my new system is 1, 2, -3, 9. My new row 2 is 0, 1, -41, and 30. And then row 3 I didn't touch. That's 0, -7, 5, and -24. So now that I've got the 1 in that spot, I want to zero out the 2 and the -7. I want those to be zeros. So how do I get that? Well, I'm going to take -2 multiples of row 2 and then add that back into row 1, and that's my new row 1. Likewise, I'm going to take a positive 7 multiples of row 2 and add that into row 3, and that'll become my new row 3. So row 2, sorry, doesn't change. 0, 1, -41, and 30. But here, -2 row 2s, so -2 times 0 is 0, plus 1 is 1. -2 times 1 is -2, plus 2 is 0. -2 times -41 is a positive 82, plus row 1 is -3, so that gives me 79. That's ugly. Then -2 row 2, here is -60. And then plus row 1 is plus 9. So that gives me a 51, -51. And then on the bottom guy, 7 row 2s. So 7 times 0 is 0, plus 0 is still 0. 7 times 1 is 7, plus -7 is 0. And then 7 times -41, that's ugly, is 287. It's negative, plus 5. So that's -282. And then 7 times 30 is 210, plus the row 3 element of -24. It's possible I've made a mistake somewhere because these numbers are just horrific, but let's see. Yeah, let me throw this into an online calculator really quick and just check. 1, 2, negative 39. Yeah, I've messed up somewhere because they should be nice values. So maybe you can spot it, maybe you can't. But there is a mess up at some point. And it's easy to do because there's a lot of arithmetic happening all in one go. I don't immediately see it though. Oh, I see it. And unfortunately, it happened all the way back here. So it's right here. If I take negative 2 times row 1 plus row 2, well, negative 2 times negative 3 is a positive 6. And then I add row 2, that number right there should be an 8. And what that unfortunately means is that everything that I've done down here is garbage. So that's a little sad, but I can go all the way back up here and start again, right? I found my mistake. And again, it's very easy to make a mistake like this. Mostly it comes from trying to go too fast, which was the case right here. I didn't write it down. But let's do it. Let's just back up to that spot and we'll continue on from there. So I apologize for that. Everything else looks okay there. Negative 2 times 9 is negative 18. That's negative 26. And then negative 3, negative 7, positive 9, 8, 7, 6, 5. And then negative 27, 6. Okay, everything looks good from here. So my apologies. We're here though. So let's keep going. I still want to get this negative 5 to be a 1. So I'm going to take that same process and I'm going to go negative 3 multiples of row 2 and add that to positive 2 multiples of row 3 to become a new row 2. And we will be careful from this point and actually write everything out. So 3 row 2s is 0 times negative 3 is 0. Negative 5 times negative 3 is a positive 15. Negative 3 times 8 is a negative 24. And then negative 3 times 26 is 78. And then 2 row 3s is 0, negative 14, 10, and negative 48. So that is 0, 1, negative 14, and then 30. And that's my new row 2. So I have this system here. 1, 2, negative 3, 9. And then my new row 2 is 0, 1, negative 14, and 30. And then row 3 didn't change, so that's 0, negative 7, 5, and negative 24. Now that I've got this 1, I want to zero out the 2 and the negative 7. So the math at this point is going to be the same. It's just going to be with different numbers because of that little mix up there. But I'll take negative 2, row 2, and add it to row 1. And then I'll take positive 7, row 2, and add it to row 3. So negative 2 row 2s would be negative 2 times 1 is negative 2. Negative 2 times 2 is negative 4, and negative 2 times negative 3 is a positive 6, and then negative 2 times 9 is negative 18. Plus row 1, well, crap, that's what I just did. Yoink. Negative 2 row 2s is negative 2 times this row. So negative 2 row 2s is negative 2 times 0 is 0. Negative 2 times 1 is negative 2. Negative 2 times negative 14 is 28. And negative 2 times 30 is negative 60. And then I'm going to add row 1, which is 1, 2, negative 3, and 9. So my new row 1 is 1, 0, 25, and negative 51. Row 2 doesn't change, so I'm just going to write that in here. 0, 1, negative 14, and 30. And then row 3, we're going to take 7 times row 2 and add it to row 3. So 7 row 2s is 7 times 0 is 0. 7 times 1 is 7. 7 times negative 14 is negative 98. And then 7 times 30 is 210. And then I add row 3, which is 0, negative 7, 5, and negative 24. So my new row 3 is 0, 0, negative 93, and positive 186. All right, these numbers are looking better, even though they're big, because 186 is divisible by 93, so that's good. Okay, we're almost there. We've got 2 of our 1s, right? So that's, we've done 2/3 of the work, and fortunately we did the very much difficult 2/3 of the work. So let's keep going. I next want to turn this negative 93 into a 1. I can't mess with the other 2 rows in order to make this happen, because if I do, I'm going to mess up with my X or my Y value in that row, and I don't want that. So I'm just going to take 1 negative 1 over 93 and multiply it by row 3. And that's my new row 3. So I end up with still 1, 0, 25, negative 51, 0, 1, negative 14, and 30. And then 0 times negative 1 over 93 is 0, or 0 divided by negative 93 is still 0. Negative 93 divided by negative 93 is 1. And 186 divided by negative 193 is negative 2. So right here, this tells us z equals negative 2. And the last thing that I want to do is to zero out these 2. And I can do that again by using row 3, the one that I just got, to get rid of those numbers. So I'll take negative 25 multiplied by row 3 and add that to row 1. And then I'll take positive 14 multiplied by row 3 and add that to row 2. So negative 25 row 3 plus row 1, well, 25 times row 3, negative 25 times row 3 gives me a negative 25 and a positive 50. And if I add that to row 1, that's just 1, 0, 25, and negative 51. So that's 1, 0, 0, negative 1. So my new system, 1, 0, 0, negative 1. The bottom is not going to change. That's still 0, 0, 1, negative 2. And so then the last little bit here is 14 row 3s added to row 2. So 14 row 3s is 14 times 0 is 0. 14 times the other 0 is 0. 14 times 1 is 14. 14 times negative 2 gives me negative 28. And then I add row 2, which is 0, 1, negative 14, and 30. So I've got 0, 1, 0, and 2. And we've solved the system. And again, they're not easy. There's a lot of math to these. I screwed up. I screw up these a lot just because there's so much arithmetic involved in them. So it is easy to screw them up. So you have to be pretty meticulous with every operation that you do. But that's these systems. So if you have questions on this, let me know. Shoot me an email. I can do more examples and hopefully not botch them up. But there are also examples of, like, Khan Academy's done these and they don't botch them up. And but I'm happy to do more if you don't like these ones or if you need more examples. So let me know, and thank you. That's it for today.